Next, we're going to use our skills to find data that requires cleaning. We've been provided with a data file from the Ontario Ministry of Children, Community and Social Services. This file details the number of youth by region and sentence types who are reoffenders in the youth justice system. You have a coworker that has identified that this file requires some cleaning before it can be used as part of their analysis. So we've been asked to clean this data and create a ready-to-run CSV file. The data file we're using represents the number of youth who reoffend and were convicted of a criminal offense within 2 years of completing a youth community disposition. This data has been adapted from the following data source. So let's refresh our memory about how we clean data. First, we read our CSV file into Python. We clean and restructure the data if needed. We join our data file with other files if necessary, and then we export our cleaned data to a new CSV file. Well, part one should be fairly straightforward. We just need to read the file into Python using pandas. We've done this before. So if we jump over into pandas, run our code, here we are. We have table 3 imported correctly. We see we have a few columns here. We have date of completion with an English and a French column name, the youth justice region, and we have sentence type, whether it was a reoffense, and the count. Notice how we have bilingual column names this time. Count doesn't look like a number. And in fact, we can confirm this to ourselves by printing out data.dtypes. What kind of data are we dealing with? Well, we see that we have object all the way down, which tells us we do not have numeric data at the moment. So that is step 1, reading in the data. Step 2, we need to do our data cleaning. Well, what issues exist with our data? Remember in week 3 that we can explore our data in one of 2 ways. We can either eyeball the file, just open it and take a quick look, or we can read this into Python and start poking around. And we just did that with the dtypes attribute. We could also use unique, describe, columns to get the column names. So let's poke around this file a little bit and see what issues we might run into. So first off, let's return to pandas and see, well, we ran dtypes already. We don't have any numeric data. If we print out, say, data, one of the problems we have is the column names. Let's print out the data.columns property, and we see we have very, very long column names. So for example, if I want to get the unique regions, I have to copy this entire name. And if we want to print this out to the console, I have to type in a very long column name along with accented characters. And depending on your keyboard layout, you may or may not have access to these accented characters. So one of the issues we can see if we look at the youth justice region, we see that the word central is in all uppercase, whereas the rest of the values are in title case. All of our number values have been read in as strings, and we have very long column names. So the big issues we have, long column names. We can do this by providing a list of new names. We'll do data.columns equals fiscal year, region, sentence type, reoffend, and count. This will save us having to type out long column names every single time. Region column has a central region in uppercase, and all our number values have been read in as strings. First, let's rename our columns. So we're going to say data.columns equals fiscal year, comma, region, comma, sentence type, no space, comma, reoffend, and comma, count. This now gives us a cleaned list of columns. This will make this file easier to work with. Next, before we convert the count column, because when we were exploring it earlier, we could see via the dtypes function that we do not have numeric values in the count column. Is there a way to identify values that cannot be converted to numbers? We can use the isNumeric function on the column's string str accessor, and this will give us a true or false result. It will return true if all the characters can be converted to a number, and it will return false if at least one character is not a number or the value is a blank or a null. So let's build a filter condition to see which rows have non-numeric values. So I'm going to create a variable here called non-number rows filter, and this will be equal to data count column dot str.isNumeric equals false. So this will give me back all the rows that cannot be converted into numbers, and I will create a new data frame called non-number rows equals data filtered by non-number rows filter. If I run this code and then inspect our non-numbered rows, I can see that I have a couple of rows that have a count that is not a number, and likely this comma is preventing us from converting our values to numbers. So now that we know the count column has comma values and values greater than 1,000, we'll apply our cleaning technique from previous modules. We're going to use str.replace to replace commas with nothing. So we'll come back into Spyder, and we'll say the counts column, I'll create a new variable called counts, set it equal to data count. Counts is equal to counts.str.replace. Replacing comma with empty string. Counts is equal to pd.toNumeric. The counts column. Data count is equal to counts. If we run this code and inspect our data frame, we'll see that all of our counts are now numbers. As our last step, we're going to use str.replace to replace the uppercase central with central for our region. And finally, we will export our data to a brand new CSV file. Let's do that now. I'll say regions equals data region. Regions equals regions.str.replace. Central uppercase with central title case. And data region equals regions. And finally, we can write this out to CSV by using toCSV, table 3, 24, 26, cleaned, .csv, index equals false. And if we run our code and inspect our data frame, we'll see that all of our central regions are now title case central. And if we look at our Files tab and open up 2426 cleaned, we'll see we have our cleaned data frame.